Hello everyone, welcome to the class. This is the second video on study of gas laws. Okay, so in first video I have already explained you some properties of gases. What are the things that we need to discuss in this chapter? Okay, three parameters: temperature, pressure, and volume are needed to study gas laws. That also I have explained in the previous video. So in today's class we will be starting. First of all, we will study about temperature. Okay, next we will study about pressure, and next we will study about volume, and then we will proceed to Boyle's law. Okay, so first of all, temperature. You can write a question. Okay, define temperature and give its various units. You write that question. Okay, so temperature you have already studied in junior classes. It is the degree, T-E-Z-R-A, degree of hotness, H-O-T-N-E-S-S, hotness or coldness of an object. We are studying gas laws here. Okay, so object means anything, object or matter you can write, solid, liquid, and gas, anything. Degree of hotness, how much hot or cold is an object. That degree of hotness is called temperature. Okay, its SI unit is Kelvin, Kelvin. Kelvin. Symbol is K, capital K. SI unit is, SI stands for System International. Internationally followed system for the unit of temperature is Kelvin. Okay, and there are some other units of temperature also. Other units is uh, degree Celsius, CLCIUS, Celsius, or sometimes we say degree centigrade also. Okay, so degree Celsius, symbol is this, degree capital C, or you may say degree centigrade also. And another unit is Kelvin, I have said, degree Celsius said. Next is Fahrenheit, Fahrenheit, Fahrenheit. Its symbol is capital, okay, degree capital F. Fahrenheit is also there. Okay, degree F. So temperature is the degree of hotness or coldness of an object. Okay, and then SI unit of temperature is Kelvin. Other units of temperature is degree Celsius or degree centigrade. Okay, and Fahrenheit. After that, you may note one thing. You may note this one. Okay, that I'll give you in next question. Okay, next question, write on state the relationship between degree Celsius and Kelvin. Number one is degree, DAZRA, degree Celsius, CLCIUS, Celsius and Kelvin. Number two, degree Celsius and Fahrenheit, FAHRENHEIT, Fahrenheit. Okay, so in answer you write the relationship between degree Celsius and Kelvin is, number one, degree Celsius and Kelvin is K is equals to 273 plus C. K means Kelvin temperature. Okay, temperature in Kelvin scale, and C means temperature in Celsius scale. So K is equals to 273 plus C. This is very, very important relation. So you should remember this relation. Okay, while doing numericals, we have to use this relation. And number two, relationship between degree Celsius and Fahrenheit is C by 5. C by 5 is equals to F minus 32 by 9. This also you note down. Okay, C by 5 is equals to F minus 32 by 9. C means, C stands for Celsius reading, F stands for Fahrenheit, FAHRENHEIT, Fahrenheit reading, and K stands for Kelvin reading. Celsius scale reading, okay, SCAL scale, Celsius scale reading. F stands for Fahrenheit scale reading and K stands for Kelvin scale reading. So relation between Kelvin is and Celsius is K is equals to 273 plus C, and degree Celsius and Fahrenheit is C by 5 is equals to F minus 32 by 9. So we have already discussed about temperature. Next question you write it. Mention question, okay, mention three important scales of reading along with their lower and upper fixed points. Mention three important scales for temperature reading along with their lower and upper fixed points. Okay, answer added. Answer: the three important scales for temperature reading are: number one, Celsius scale or centigrade, 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 centigrade scale, Celsius or centigrade scale. Number two, Kelvin scale, and number three is Fahrenheit, FAHRENHEIT, Fahrenheit scale of temperature reading. Okay, three different types of scales we use for reading temperature. One is Celsius scale or centigrade. This spelling you check it in your book. Okay, I'm not sure about this spelling, CNTE or CNTI. Check it, this one. Okay, Kelvin scale and Fahrenheit scale. Next, you make the table. Okay, number one, your lower fixed point, lower fixed point. Next is upper fixed point here. Number one, Celsius scale. Number two, Kelvin scale. Number three, Fahrenheit, Fahrenheit scale. For Celsius scale, lower fixed point is 0 degrees Celsius, 0 degrees Celsius, capital C. Okay, upper fixed point is 100 degrees Celsius. Kelvin scale, lower fixed point is 273 Kelvin. Don't write degree here. Okay, just Kelvin only. 273 Kelvin. Upper fixed point is 373 Kelvin. Lower fixed point is 273 Kelvin and upper fixed point is 373 Kelvin. This is a Fahrenheit scale is 32 degree Fahrenheit and upper is 212 degree Fahrenheit. Lower fixed point is 32 degree Fahrenheit and upper fixed point is 212 degree Fahrenheit. Okay, so 0 degree Celsius is equals to 273 Kelvin, and that is also equals to 32 degree Fahrenheit, and 100 degree Celsius is equals to 373 Kelvin, and that is also equals to 212 degree Fahrenheit. Okay, so in objectives you may get some simple questions like how much is 0 degree Celsius in Kelvin scale. Then you should say 0 degree Celsius is equals to 273 Kelvin. And sometimes you will be asked how much is 0 degree Celsius in Fahrenheit scale, and in that case you should say 0 degree Celsius is 32 degree Fahrenheit. Okay, and sometimes you might be question might be mention the lower and upper fixed point of Kelvin scale. Lower fixed point is 273 Kelvin. Upper fixed point is 373 Kelvin. And similarly, if you are asked mention the lower and upper fixed point of Celsius scale, then you should say lower fixed point is 0 degree Celsius and upper fixed point is 100 degree Celsius. Okay, or 100 degree centigrade also. Next, let's proceed to pressure. Okay, pressure. Write down the question. Okay, define pressure and mention its various units. So definition of pressure is, it is the force exerted, it is the force, force, force exerted, exerted, exerted per unit area. It is the force exerted per unit area. Mathematically, mathematically we define pressure, pressure, pressure by pressure equals to force upon area. Okay, area. See, definition says that force is the pressure is the force exerted per unit area. Per unit area means 1 meter square or 1 centimeter square or 1 millimeter. So per unit means always 1. Unit means 1. Okay. So pressure is, it is the force exerted per unit area. Suppose you have, say, this is 1 meter and this is 1 meter. If you apply some force on this region, this 1 meter, this region, okay, if you apply some force, then that force, whatever force you apply on this area, unit area of this one, okay, that is called pressure. Mathematically, pressure is defined as force upon area. So unit of pressure, unit, unit of pressure. SI unit of pressure, pressure is, unit of force is Newton, area is meter square. So Newton per meter square. This is Newton per divided by meter square. We can write like this. Okay, Newton per meter square. Or this Newton per meter square is called Pascal, Pascal, Pascal. Symbol is capital P small a. SI unit of pressure is Newton per meter square. This N stands for Newton, okay, N-E-W-T-O-N, Newton. It is the SI unit of force. And this meter square, per meter square, per means this minus is in the power, okay. So we did Newton per meter square, Newton per per MET meter square, Newton per meter square is the SI unit of pressure. And this Newton per meter square together we call it Pascal, Pascal. Pascal symbol is capital P small a. Okay, so most of the time we follow this. Instead of writing Newton per meter square, we write this. So if you are asked what is the SI unit of pressure, then instead of saying this, you say this, Pascal. Okay, Pascal, Pascal. And there are some other units also, that also I'll give you. Okay, other units of pressure. Other units of pressure are centimeter of Hg. Hg means mercury, centimeter of mercury, millimeter, mm means millimeter of mercury, Hg is mercury hydrargyrum. Okay, Latin name of mercury is hydrargyrum. So centimeter of Hg is also the unit of pressure. Millimeter of Hg is also the unit of pressure. Bar, bar, bar is also the unit of pressure. Okay. Next, so many units are there. Okay, bar, TOR, TOR, torr is also the unit of pressure. Okay, next we have atmosphere, ATM. Short form we write ATM, atmosphere. ATM stands for atmosphere. Okay, ATMOSPHER, atmosphere is also the unit of pressure. So other than this, there are some other units of pressure also. So just remember this. SI unit of pressure is Pascal or Newton per meter, and some other units are centimeter of Hg, millimeter of Hg, bar, torr, 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 okay, atmosphere, ATM stands for atmosphere. If you say this, if someone writes 5 atmosphere, okay, the pressure of the within this room is 5 atmosphere, this ATM. Suppose if someone says the pressure of this room is 5 atmosphere, then it means force exerted per unit area is 5 Newton, okay, not 5 Newton. Okay, suppose if someone says the pressure of this room is 5 Pascal PA, then on 1 meter square area of this room, 1 meter square area of this room, 5 Newton force is applied, okay, 5 Newton force is applied. So that is the pressure of within this room is 5 Pascal. You note down one thing, okay, note 76 centimeter of Hg. This is the relation between various units of pressure, okay. 76 centimeter of Hg is equals to 760 mm of Hg, mercury, 760 mm of Hg, and that is also equals to 760 torr, TORR. This relation you should remember, okay. This we need during conversion, interconversion of units, okay. 76 centimeter of Hg is equals to 760 mm of Hg, and that is also equals to 760 torr. See, 1 centimeter is equals to 10 mm. 1 centimeter is equals to 10 mm. So 76 centimeter will be equals to 76 into 10 mm. So 760 mm, okay. So pressure also we have discussed. You should know pressure is the force exerted per unit area. In 1 meter square area, how much force is exerted, and that is called pressure, okay. Now next question, you write it. Define the SI unit of pressure, that is Pascal, PASCAL, Pascal. Define the SI unit of pressure, that is Pascal, okay. So definition of Pascal, 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 symbol is PA. See, I'll give the definition from here, okay. So this is the definition of Pascal. 1 Pascal is equals to 1 Newton divided by 1 meter square. So in sentence form, you should say, if 1 Newton force is applied on an area of 1 meter square, then the pressure exerted on that area is called 1 Pascal. Okay, so if, write it for me, if 1 Newton force is applied on an area of 1 meter square, then the pressure on that area is said to be 1 Pascal. Mathematically, pressure, we know pressure is equals to force upon area, okay. From here, if you put the unit of pressure is Pascal, so just write 1 Pascal, okay, is equals to unit of force is Newton, just add 1 in front of Newton, and area, SI unit of area is meter square, just add 1 in front of this. So 1 Pascal is equals to 1 Newton upon 1 meter square. So if a force of 1 Newton is applied on an area of 1 meter square, then the pressure is said to be 1 Pascal. Next, let's move to another topic, that is volume. Okay, VOLUME, volume. Write down question, define volume and give its various units.